Hello chemists, I'd like to introduce a few more concepts about drawing organic molecules. First one is what you see right in front of you, which is what we've been calling the university method of drawing organic molecules. This is not the way that you've been drawing organic molecules so far, and it's not the way you should draw them on the exam, but if you're doing internet research about organic molecules, this is what you'll often see, so I thought that I should go over what it means. So, chemists are lazy, and as lazy people, what they want to do is draw and write as little as possible. So instead of writing a carbon, and then a line, and then a hydrogen, etc., what instead they will do is just do what you see here, which is just these lines. And what these lines mean is every place there is a vertex or line end, there is a carbon. So all of these places here have carbons on them. And each carbon just has as many hydrogens as it needs to fill its octet. So this one here is going to have 3 carbons attached to it, so that's going to be CH3. This one here is going to have 1 hydrogen because the other 3 parts of its octet are going to be filled with this bond, and this bond. This one here will have 2, hydrogen here and hydrogen here, because these 2 bits are all filled with the bonds to the other carbons. So basically, what you should see when you look at one of these is a carbon everywhere a line ends or intersects, and just assume that every carbon is full of hydrogens. So that is a way to let me start talking about what are called side chains. Side chains is what if your molecule isn't just one long chain? What if it's got a little bit coming off the edge? Well, then we have to include that in the name. When we name a molecule, we name every side chain based on its location and also its type. So locations are numbered. First, you find the longest single carbon chain. In this case, our longest single carbon chain is 1, 2, 3, 4, 5. And that means that the whole molecule is going to be a pentane. Then what you do is you find all of the things that come off of that single chain. So we've got this, we've got that, and we've got that. Those are all 3 methyl groups. So this is going to be what's called a trimethyl pentane. That means 3 methyl groups on a pentane, but we have to say where those methyl groups come off of the pentane. And the way you do that is by numbering. When you number a molecule, you want to start counting from one end or the other and just number your carbons. So we can do 1, 2, 3, 4, 5, or just as accurately, we could do 1, 2, 3, 4, 5. The thing with numbering is you want your numbers to be as low as possible for all of your side chains. You want to keep your numbers for locations to be as low as you can. So we're going to stick with this numbering because we want to indicate that there are some methyls coming off of the 2 position and the 4 position. If we did it the other way around, they would be coming off at I guess it'd be coming off the 2 position and the 4 position as well, but you'd have 2 at the 4 position rather than 2 at the 2 position, and we want to keep all of the numbers as low as possible. So basically you've got 2 methyls coming off of the 2 position and 1 methyl coming off of the 4 position. So what you do is you say 2, 2, 2, 4 trimethylpentane. 2, 2, 4 trimethylpentane. And what that means is a methyl at the 2, another methyl at the 2, a third methyl at the 4, and there's 3 of them in total. So 2, 2, 4 trimethylpentane, a methyl at the 2, another methyl at the 2, a methyl at the 4, total of 3 of them, all methyls, and they're all on a pentane. And you can do that side chain naming thing with all sorts of stuff. You can do that with halo alkanes. You can name where the bond comes in an alkene or an alkyne that way. If the double or triple bond is at the 2 position, you could call it 2-pentane or 2-hexine, hexine, and yeah. So basically identify your longest chains, identify your side chains, number them based on location, not on how many they are. The number does not refer to how many there are. The number refers to location. And then stick it all on the bit that indicates the longest single chain.